Hi guys, today we're going to be talking about lights in the 3D space in Fusion within Davinci Resolve. Let's get to it. Let's put in the Fusion comp. That's under Effects, on the Toolbox Effects, Fusion comp. Let's go to the Fusion page. So there are basically 4 lights in the 3D space in Fusion. The best place to see them all stacked together is under Effects. Under Tools, you'll see Lights. All 4 lights are here. So let's pull them all in. Ambient light, Directional light, Point light, and Spotlight. All 4 of them have an orange input. That orange input, you can connect a 3D mesh to it. You can also connect another light to it. As long as it's a 3D node, you can connect it to this. Now to each of the lights. Let's start with ambient light. Let's put in a 3D mesh as a shape 3D. Let's bring in a merge node. To use lights, the standard way to use light is to connect it to a merge node and connect the 3D mesh to that merge node. Let's drag that to the right viewer. Let's make this a single viewer so we see what we're working with. For shape 3D, let's make it a cube. Okay, so let's bring in a renderer node and connect this to the renderer node. The renderer node, let's enable lighting and let's drag this to the viewer. So we see this thing here. Let's rotate the object by going to Transform tab and rotating it a bit so we get to see it, and maybe pull this down like that. You'll see that ambient light doesn't give the 3D shape definition. It just essentially brightens the whole scene evenly. If I increase it, you see it just increases it, reduces it. That's all it does. It doesn't give it definition. And then you can change the color of the ambient light. You can change it to something like purple, so it casts a purple hue on the object, right? On the 3D scene, you can have multiple objects in here and to give them the same color tint, right? You can increase the intensity of it, you can reduce the intensity. Then in transform, with ambient light, if you move X or Y or Z, it doesn't have any effect. So transform does not have any effect on ambient light. It is just so moving it around doesn't change anything. That's that for ambient light. And now for ambient light also, it does not cast a shadow. Let's move it back, disconnect it. We move on to directional light. Let's connect that to the scene. Bam. This gives the shape definition, as you can see, but it does not cast a shadow. Ignore that there is a shadow setting here. It does not cast a shadow. Then also you can give it a color tint, but there's still some level of definition. But for directional light, what happens is if you move the translation up and down, nothing happens, because for directional light, it's almost like the sun. So it's rotation that has an effect on it. If I move it about, you see it has an effect on the scene. You can rotate it X, Y, or Z, then it has an effect on the scene. But translation effects, X, Y, Z does not have an effect on it. That's for directional light. Or you can drag the 3D, merge 3D here. Let's zoom out a bit to 25. You can move it around. Okay, so there it is. So you see it here. So that angle we put it at, but you see this thing here shows where it is pointing to. If you wanted to point to this, you just rotate it like that. So it would be the sun shining on the object. Okay, so that's how directional light works. Let's disconnect that. Let's even make it a dual viewer. Let's close Effects tab. So we can bring renderer on the right viewer and bring merge 3D to the left viewer. Let's connect point light to merge 3D. And you'll see that nothing really seems to have happened, right? You can, as always, for all of them, you can change the color it projects on the image, but it doesn't seem to have any effect. It's because it's within the object. This is merge 3D one here. It's within the object, so you need to pull it out. So we can go to transform and we pull it out, and then you see it shining across. Okay, so that's how point light works. Notice that there's no rotation for it, because rotating it doesn't change anything, because it shines the light evenly round about it. That's how that works. You can change the shine type to linear, quadratic. Quadratic is more along the lines of how light shines realistically, but linear it looks nicer on the screen because it reduces the light intensity in direct proportion to the distance from the object. All right, you can reduce the decay rate, increase the decay rate, and ignore the shadow thing. It does not cast a shadow. All right, it doesn't cast a shadow. How do I verify this? I can bring in an image plane, connect an image plane to this, and let's increase the size of this image plane like so. Let's make the image plane material to white. That's fine. This point light, we can move it back a bit more so that we can see the light on the image plane. As it is, it's supposed to cast a bit of shadow. Let's go to Renderer 3D and enable shadow. It's supposed to cast some shadow on this image plane, but it is not doing that. If I go to the point light, I can move it around. It never casts a shadow. All right. So ignore that it has shadow listed here. It does not cast a shadow. Let's disconnect that. And then finally, we go to Spotlight. If you want to cast a shadow on an object, you use Spotlight. Let's move it to 25% so we see where it is at. You see, it doesn't seem to have any effect on the scene. It's because it's in the center of the scene, so I need to move it out. So I go to Spotlight. Under Spotlight, there are some settings: the color settings, the decay type, the cone angle. The cone angle is usually 40 by default. I usually increase mine to 90 to increase the coverage. The penumbra angle, let me show you how that works. Let's go to transform. Let's move it back by increasing the Z value. So you see that. So you see the edges of the light. If I go to controls and I increase penumbra angle, it softens that edge of the light. That's what that does, right? Then this drop off can now contract the softened edges. That's how that works. Then you see under here shadows. Now, let me move it around so you can see it cast a bit of shadow. Let's move it to this side. Let's move it down actually. Let's move it down a bit. Then I want to rotate it up. I can click on this red, I'll rotate it up. You can already see that it is casting a shadow of this box on the image plane. Okay. Now, like I said in the Renderer 3D last week, the rendering of shadow on the software renderer is better and more consistent on software renderer than it is on OpenGL renderer. So if we go to the spotlights, we can now go to shadows and you can set the color of the shadow. You can set the density. If I increase density to 1, it becomes this. Then if I reduce that, almost like it dictates the opacity of the shadow. Then I go to multiplicative bias and additive bias is where you have multiple objects casting shadow on each other. I really don't touch the shadow map side, shadow map proxy, multiplicative bias, additive bias. I don't touch these. I just ignore them. Then I move to the sampling quality. I leave it at medium. But what I also do is I make sure the softness, I make it variable fast. So you see it cast a shadow. If you want to be a little better, you can say variable, and then it's just like a regular shadow, right? Then if you put constant just leaves the shadow the same intensity from closer to the object down to the end of the object, but I usually leave it at variable fast. So it's a bit sharper here, then it gradually fades off to gets blurrier as it moves away from the object. So that's how shadows work here. And if I decide to now move the slides, you can see the shadow moving like that. You can move the X, you see the shadow moving like that. All right, so that's how that works. Here, there you can move it around. You can change the rotation. Translation works for spotlight. Rotation works for spotlight, and the pivot also works. Now, let me just do a little thing here to drive this home. This cube. Let me disconnect this cube. Let's bring in text 3D. Connect this text 3D here. Let's say resolve. Let's increase the size. Then let's go to extrusion and give it like an extrusion of 0.2. It looks like the size is a little too big. I reduce the size a whole lot, like that. Something like this. Let's reduce it a few further. Great. So you can see how, if I now decide to move the spotlight, let's assume I pick the spotlight and I move it here. And this spotlight, let's assume I say use, I want to pick a target I want to use. I can click and drag, and I want to use this as target. Then I can go to spotlight and I can now move this so it always focuses on the text. I go to here and I drag it here. Okay. And I keyframe it here. And keyframe it here. And I go to perhaps, let's say 30. And I drag it here like that. Something like that. So if we play this, you see the shadow moving across like that. Something like that. This is the kind of quick and dirty, right? But you get the drift. If we move the light further backwards, we can make this shadow look a little nicer. So that's basically it for the lights in 3D in Fusion. And I hope you learned one or two things. These are just quick and dirty, straightforward, basic things that you need to be able to get up and running in 3D space in Fusion. And next week, we are going to be doing like a model, a book opening, all done completely in Fusion. All right, so looking forward to sharing that with you. Thanks for joining me on this one, and have a nice one. Cheers.